All right, on this video, I'm going to show you how to find the derivative of things when the y is not by itself, or it would be really difficult to get the y by itself. Everything we've been doing so far has been in the form of y equals some equation. So in this one, you have a y to the third and you have a 9xy. So to try to get the y alone would be a mess. So what we're going to do is just take the derivative the way we've been doing it, and when we get to something with a y in it, we're going to use chain rule. So the derivative of x cubed is still 3x squared, and then the derivative of y to the third would be 3y squared, but then it's times the derivative of the inside, so times y prime. Then when you get to something like this xy, this is product rule. I like to think of the minus 9x as the first part and the y as the second part. Like you could do minus and then the whole product rule with the parentheses, but I just like to think of the negative as going with the 9x. So the product rule is first times the derivative of the second plus the second times the derivative of the first, and then equals the derivative of 0 is still 0. Then you want to get your y primes alone because we're still trying to solve for y prime. So I want to have this and this on the left side. So 3y squared times y prime minus 9x times y prime equals a positive 9y minus 3x squared. Now I'm going to factor out a y prime, leaving me with 3y squared minus 9x. And we could divide by 3 here. I'm just going to do it at the end. So then I'm going to get y prime alone by dividing. So 9y minus 3x squared divided by 3y squared minus 9x. And then divide everything by 3, giving me 3y minus x squared over y squared minus 3x. So now you have a formula for the slope at a point. You know, remember the derivative is the slope at a certain point. Before, if we had something as simple as y equals 5x squared plus 1, then y prime was 10x. And so y prime at 3 was 30, so that means, you know, your slope is 30 at x equals 3. Well, this, you would have to plug in an x and a y. You'd have to find, you know, let's say you wanted x equals 1, you would have to plug 1 in here for x, find the y that goes with it, and plug both of those in for x and y to get your slope at that point. And you can graph this on Desmos if you want to take a look at it and see what it looks like, and plug in different values if you want to, and play around with that. Okay, another example is a circle. Let's say you have x squared plus y squared equals 25. So that derivative is 2x plus 2y times y prime equals 0. Then I'm going to just cancel my 2's out and then move this over. So y prime is negative x divided by y. So some of them are pretty short, some of them are longer. We might have one where you're asked to find the second derivative. So let's say you have 2x cubed minus 3y squared equals 8. And we want to find the second derivative. So you start by finding the first. So 6x squared minus 6y y prime equals 0. So I'm going to divide by 6. And then negative y prime equals negative x squared divided by y. And so y prime is x squared over y. I did that kind of funky, but I think you see what I did. So now the second derivative is the derivative of the first, so now we have to use quotient rule. So the second derivative is bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Well, y prime is what we just found, so we're going to substitute that in. So y double prime is 2xy minus x squared times x squared over y all over y squared. And now we don't like to have a fraction within a fraction, so I'm going to multiply everything by y. to get those y's to cancel out. So that's going to give me a second derivative of 2xy squared minus x to the fourth all over y to the third. Okay, let's do one more with some trig functions in it. So this is the fourth example. So let's say we have y squared is equal to x squared plus the sine of xy. So 2y times y prime is 2x. The derivative of sine is cosine. Leave the inside alone, times the derivative of the inside, which is a product rule. So first times the derivative of the second, plus the second times the derivative of the first. So now again, we want to get our y prime alone. So we've got 2y, y prime, and we've got a 2x, and now I'm going to distribute this. So plus x y prime times the cosine of xy plus y times the cosine of xy. So I'm going to take this and move it over. So 2y y prime minus x y prime cosine of xy is equal to 2x plus y cosine xy. Factor out a y prime, 2y minus x times the cosine of xy is equal to all of this. And so y prime is this numerator, 2x plus y cosine of xy divided by 2y minus x cosine of xy. So it's just using all of the rules that we've learned before, and now we're treating y kind of like a chain rule. So hopefully that makes sense to you.